we're seeing this transition from AI that I don't think the majority of the world really understand.
You can't automate a bad process and make it a good process.
You may have been able to have the luxury of waiting in the past to digitize your systems. You cannot feed analog data into AI nearly as well as digitized information. Every 20-person shop, if they make this transition correctly, will go from being a $5 to $6 million company to a $20 to $30 million company without any more people.
Welcome to the Next-Gen Metal Fab Podcast. I'm your host, Tim Heston. In each episode, I'll be joined by a rotation of co-hosts. Caleb Chamberlain from Oshkosh, Cody Lee from Everyday Technologies, and Lance Thrakill from All Metals Fabricating. Together, we'll talk about what the future could look like for precision sheet metal and tube fabrication.
Want to level up your manufacturing or metal fabrication career? Fabricators and Manufacturers Association connects you with the education, training, and community you need to stay ahead. As an FMA member, you'll get access to exclusive resources, industry events, and a network of professionals who share your passion for making things better. Join today and start building your future in manufacturing at fmamfg.org. And now, back to the episode.
Hi, this is Tim Heston of the Fabricator Magazine at the Fabricators and Manufacturers Association, and thanks for joining us for this episode of the Next-Gen Metal Fab Podcast. And this time we're kind of switching it up from our normal panelist of fabricators, and we've got Sunny Han of Fulcrum, innovative software company, kind of really made inroads into the metal fabrication and custom metal fabrication job shop markets particularly. So Sunny, how you doing?
Doing great. How are you?
Oh, just fine. Just kind of wanted to get the conversation started by your background. You know, how did you get into the software business?
Accidentally. My mom studied computer science when she was in grad school. I moved to Minnesota when I was 4 years old and started dinking around on her computer when I was 6 and learned C and C++ by the time I was in elementary school, and started taking classes at the University of Minnesota for math and computer science right around that time, and just built websites. This was in the early 90s, mid 90s, learned web development, just bopped around the internet a bunch.
And how did you focus on job shops in particular, though? Because that's an interesting software niche to actually try to tackle and unpeel.
A bit of a detour, just like, your daughter just started undergrad. I took all that experience and thought, why don't I turn this into a career in medicine? So I actually studied medicine in undergrad, didn't do very well, played video games instead of going to class. But that detour kind of set me off after school on a what do I do with my life kind of a vibe. It was 2008. Was potentially going to go work for a bank that didn't exist anymore, and instead got a job in consulting. And my first set of companies that I worked with were manufacturers. They were sheet metal fabricators and CNC shops. And if you remember at that time, there were certain industries like recreational vehicles where half of those revenues were going away and they were distressed. And so I saw a lot of really sad businesses over a period of time. But it was accidental. And no point in time did I say, oh, I'm going to write software for them. It wasn't until much, much, much later in life. Because as a kid, I just thought, oh, these really large businesses, they have a lot of money, they have a lot of customers. They're the ones that are going to go keep building their software. But every year that went by, I realized more and more that just isn't their business model, that they have really good revenue streams and there's no interest in building something new, and started a company to try to address that problem almost 10 years ago now.
Awesome. You know, we've had many conversations in the past about this off and on at various conferences. We're actually recording this at the FMA annual meeting here in sunny Florida at 48 degrees. But hey, works for us. Dick Kallage, who used to write for the magazine, he's passed away several years ago, unfortunately, but he kind of was an inspiration to how I look at shops. He was a consultant that said, all right, what's the largest waste in a growing job shop, specifically when you're under 10 million? And as you progress toward that 10 million and especially 20 million, depending on if you're sheet metal plate and what kind of part mix you have, he called it information waste. So much information waste. You get chaos on the floor. So when you visit a job shop and look at the information chain, what do you look for? It's like, all right, these are issues that software can address, and alternatively, here are some other issues that, hey, these are baseline issues that, hey, you just need a process map, and you're going to map it so that otherwise, as we've said here at this conference, you can't automate a bad process and make it a good process. So kind of dig into that.
Yeah. So I know this might be a little bit of a last minute change, but even since we first started talking about this podcast a month ago, there's a lot that's changed from a technology perspective.
Yeah.
I've met founders of software companies that have grown to $100 million in revenue with less than 10 people. And in the software world, we're seeing this transition from AI that I don't think the majority of the world really understands. And I would say my answer to that question 2 months ago would have been what I've been saying for years. But today, what I'll say is that I would imagine that every 20-person shop, if they make this transition correctly, will go from being a $5 to $6 million company to a $20 to $30 million company without any more people. I think that is the type of transition that's happening. And the danger is that it's no longer actually about process. It's actually just about the information itself. If your people aren't seeing the information in a clear way and digesting it, then they won't match the speed of the systems that are going to start emerging over the next year. And process only emerges when the speed of transfer is stretched out over the course of months. You do a job, you put stuff into a piece of paper, you enter it into your ERP, you print out a report, you go to a production meeting, you see if you made money or not. You're going to be both seeing and transacting things live. So when you start taking a 3-month process of job costing and compressing it down into 30 minutes, well, now process doesn't really mean anything, right? You're kind of seeing everything all at the same time. You need to be able to see everything all at the same time. And your intuition of how timelines work in process, I think everywhere, including in sheet metal fabrication, is going to change very, very quickly.
So what would have been your answer 2 months ago?
2 months ago, I would have said that just having live data and not having meetings and not having this coordination tax and not having to, plan things as much, being able to react much more ad hoc, maybe to the week or to the day, that would have felt really fast already for a lot of companies that we work with. But I'm saying we're about to go warp speed now.
Yeah. So by warp speed, in other words, all right, you're saying, all right, the laser's cutting, and then I'm getting real-time costing data from that. In other words, is that like that real?
Or there's an agent that's collecting all your previous data and forecasting that even from the first time the laser turns on, the first blank that comes off, we can start to project if this is going to be profitable or not. And so we'll know before the job is finished the probability that we're going to make money on this. And we're going to take that information and it's going to spit into the next quality assessment we do for the next customer, or the next, when can I promise this next order to the customer, or adjust the purchasing plan for the very next run of this. Maybe you have a blanket order and there's, 45 releases that you have over the next year. Well, we can automatically adjust every future release to have a different cost profile, a different purchasing profile, a different timeline profile. And that'll make better data for the scheduler for the next time that things happen.
So do you have different data points for, say, the machine time, but also your queue time? So how does that fit in? Because I've seen shops where they have the costing is machine time, and yet the customer was pissed because it sat as WIP forever because either an outside supplier, there was some kind of miscommunication, and so yeah, they were great, but the plating supplier took forever or something to that effect. You always look at a Gantt chart of from your quote to cash, or more likely from your order release and raw stock to the shipping dock, and it's literally like a couple hours, maybe even just less than an hour of actual tool hitting the metal.
Right.
And most of it's just sitting in between processes
Right.
in queue time. So and there's a cost to that. So
For sure.
so how does real-time costing fit that reality?
Yeah. I mean, in academic speak, we call that make span. So from the first time a material is pulled from the very beginning until it's actually shipped off, like what is that total make span of that particular job? This real-time costing is not real-time costing. It's like real-time costing related decision loops, I guess. It's like, imagine if you were there's no computers except all the data in your shop is just fed right into your brain. What would you do with that costing data? Well, the very next time you see an email come in, you respond to that customer differently. And the very next order that you make, you would have all that information encoded in your next decision. The thing to think about is that how much time goes by between when you lost money on a job right now and you actually affect your decisions. A lot of time. And a lot of those decisions don't even get captured because you don't apply it all the time. You don't remember it. It's a small little thing.
Right.
Imagine a world where every single time something happens, every decision downstream is instantly affected automatically.
Right. So and made automatically, or are people still making that decision?
I mean, that's up to you and how fast you wanna go. But I imagine a future where your preferences as a shop owner, as a production manager, are encoded into a software system. Now, a lot of people are like, "Well, that's gonna really automate my job away." That's not entirely true. Just like the stock market, the entire economy is made up of a bunch of different preferences and wishes. And sometimes your wishes, your preferences, your ideas, they work really well and you make a lot of money. Sometimes they're really boneheaded ideas and you lose a lot of money.
Right.
But what I imagine is that there's gonna be a group of humans that are just gonna be preference engines. They're gonna say, "This is a new idea. This is my taste. This is my judgment on whether or not this is a good idea and whether we should do it or not."
Right.
And that job is the job that's the most fun for every business owner, every production manager, every person, I think.
Right.
And it's just gonna intensify. You're gonna do that all day long.
It's interesting because I think the software technology is catching up with some of the machine tool technology actually that we talked about today in the panel, where and the ATC brake, the automatic tool change brake, is a prime example with stage setups.
Yep.
Where in the past, where I've seen stage setups, they carefully crafted saying, I want to run these jobs in this stage setup.
Yep.
But can imagine a world of AI-driven scheduling saying, listen, this changes dynamically, and guess what? This automated brake is going to speak with software and say, listen, this actually is the best way to get these disparate jobs
Yep.
down to the next process as quickly as possible, part flow velocity. So we have the least amount of queue time. We're going to switch around the tools this way, and that's going to communicate directly to our scheduling software and saying, hey, that way we can I guess airline scheduling is kind of almost
Exactly.
there, and here we'll have that.
Yeah, it's like a macrocosm of what we do with nesting integrations, right?
Mhm.
Because you can nest things in different ways. You can nest different jobs together. You can nest across different components in a job, and that affects the schedule. And it actually should be a loop, but most people run their shops by running the schedule, then taking everything on the schedule and putting it in the nesting.
Right.
But actually, there's a little bit more quite a bit of flexibility in the schedule and quite a bit of flexibility in the nesting algorithms. And so in some of our better integrations, we'll have this ability to kind of talk back and forth 10 or 20 or 30 times. It'll run the nesting software ragged, but we'll get even more yields. So that's kind of the dream that we have, is this mechanical muscle, mechanical mind. The mechanical muscles are all the machines, the tool changers. The mechanical mind has been detached. A human had to take this mechanical mind that was in a little box and transmit stuff into the machine. Imagine if there was better coordination between those two things.
Yeah, and I can also see how purchasing can fit into this as well.
That's right. It's actually all one decision. How you nest, how you schedule, how you plan, how you purchase. It actually is just one algorithm.
Right, it's two sides. You told me it's two sides of the same coin. Right?
Exactly. We've detached it and given it to 3 different people, but now that we could compute it all together, it's actually one job.
Right, and then you can reduce your raw stock as much as you can and then with that side of the coin also looking out to extra, it's done manually. Like I talked to a shop the other day where they just killed it during COVID. In fact, it was the tube fabricator we talked to.
Yeah,
They killed it during COVID because they bought ridiculous amounts of material, so they hedged. There was an odd situation,
Right.
and they were a small shop, and they could just do it, and they did it. But imagine that kind of thing where you've got this kind of software looking out into the markets, going, all right, what's going on, and this is how much we should hedge, and this is the safety stock because it's still a job shop. You can't starve a job shop with no raw stock.
That's right.
So you can dynamically change that quantity, but also the quality, because another panelist here at the FMA meeting, I chatted with him at length about material quality and warping and them having to change suppliers, and the fact that everything just shut down because they tried to save money on this material, so they had to move. And so they were coordinating with quality how, okay, these are our purchasing requirements. This is the card we should go by. And I mean, it's a common issue. But to put that dynamically into a system saying, all right, we know that this material is cheaper and we can do it. And the cost, it's the overall cost. So if you can reduce the cost, and then if the lead time meets market demand, and we can make these adjustments to the machine to run this subpar material that we know has some variability.
Yep.
I mean, what are your thoughts on that as far as totally,
I think in the past, people had to choose one methodology of running their shop. We want to minimize WIP, Do we want to increase throughput? Do we want to minimize costs? Do we want to buy a bunch of stuff and build it all at the same time and store it all on our shelves? Or do we want to, reach out and look at all our releases and just build them all at once and just send them later? And you had to make a choice whether you had cash or not, or whether you had the inventory or not, or whether you could pull it off or not. But really, it was, could you process all those variables all at the same time?
Right.
Well, what we're really saying is that with computational power, you're just strapping on, an enhancement device to your brain, and now you can compute all those things at the same time, and you can do all of it. You can say, I want to minimize WIP, but I also want to increase throughput. I don't want my inventory sitting there, but I want some balance point. It's not just one or the other. It's like some correct balancing point of all these variables over time, something that our brains are actually really, really bad at. That's why we have concepts like one-piece flow, or concepts like, just build the whole assembly all at the same time and then finish it. It's easier for us to think in that way, and we get efficiencies because of operations. But if you imagine an intelligence that's really, really juiced up on computation, well, it can actually dynamically change based on the environment. And you'll never lose, because every one of those strategies loses in some environment. And
Yeah.
changing strategies in a company right now is really, really difficult.
Right.
But just imagine if you could have all of them at the same time.
And what's interesting is to dovetail into kind of in matching that with the optimum labor, because I mean, yeah, we talk about automation, but if you visit most shops these days, there's a lot of touching of the material that goes on, and you've got amazing automation in blanking and bending, but then someone manually masking parts, holes,
Yeah.
and then hanging it on a powder line, and I can see a future where software will go, okay, Joe is on the line, and he's really good at this job. He has his system down. He's done it forever. Okay, maybe Bob, he just started the other day. Give him a little more time. We're going to bake that kind of experience into the schedule so that everything talks to each other, and it could almost feed back to feedback to everything upstream.
Yeah, or let's say that you got asked to build the same part again. You had a prototype, now it's going into production, and the OEM says, I want a bunch of these. Well, we can look at the last 5 times you prototyped it and say, Tim is just always so much better than Sonny at it.
Right.
Let's ask Tim to write the work instructions for this, maybe record a video, whatever it may be.
Yeah.
We'll have data to say, it's not just loudmouth Sonny who's always out there saying how good he is. The data shows it's Tim, and Tim should be the one that records his work instruction.
Oh dear God, I should never record work instructions. I get paid by the word, No, I'm kidding. I don't actually. But the other side to that that I was thinking about is, we're sitting at a table here at the FMA annual meeting, and I've been covering the software business, for as long as I've been covering the metal fabrication business, and in the last year, it has just it's amazed me what's happening on the software level, not just at software companies, but at some of our readers. Some readers, we call them web shops. They develop their own platform, or they've outsourced a platform. But then we've got a reader who is a 10-person shop. The weld foreman literally wrote a production planning software.
Yeah, that's
through
right.
Claude.
And you're going to see that more and more and more.
Yeah.
And
Yeah.
like that change happened in the last 4 months, 5 months. Like that, not to be, I'm not trying to be disparaging or whatever, but there's a lot of stuff that was said here about AI that's a year ago. Like a lot of the content that I've heard,
Yeah.
just being circled, things are changing faster than people realize.
Right.
Like you kind of have to be in San Francisco or really reading and sifting through all the crap on Twitter and finding the actual truth that's out there to understand. But we're seeing infrastructure, tooling, we're seeing stuff change on the daily, like within hours.
Right.
Has in my history with technology, even though I was a kid during the .com bubble, it's never really felt like this. Yeah.
Now, and as I was saying, is on this table there are 3 laptops.
There are,
writing,
yes.
writing software.
There's three laptops right now that are each running Claude autonomously. Each of them have multiple agents on them. Some of them are talking to servers that are in Minneapolis in our headquarters. We bought a bunch of NVIDIA products. They're called DGX Spark. They're these desktop computers that cost like $4,000 that are specifically tuned to help train agents or to like do inference on models. Yeah, we rolled out an entire quality module in 18 days.
Right.
From the first line of code until the first customer, 18 days.
So what's your view of, there's always this talk of, the software ecosystem. I know, we have paperless parts here today. I've talked with one factory and a few others There's just some, incredible folks that want to talk to each other. But then at the same time, we've got the shops themselves putting together software. So how is all this going to work together and create something seamless and custom? Like, how are folks going to work together in the future, I guess is my question.
I think the same way, just at a different layer of abstraction. Even today, when we talk to customers, our sales team finds people who have written their own custom software on top of Visual Foxit Pro or Access or Visual Basic or some technology that they actually probably wrote 20 or 30 years ago.
Yeah.
And I think people don't remember because I think technology goes in fits and starts. In the late 80s, early 90s, just having a database itself was like a miracle, right?
Right.
But like the database was the innovation before, right? And so just like before, some people will always build their own custom thing. Like that's what they want to do. They're going to be good at it. They enjoy it. They have to maintain it and they have to tweak it and they have to adapt it to the new technology, which doesn't always happen. And then you're going to have a bunch of people that are going to provide components, picks and shovels for you to make some semi-custom software. So, we may have components that just really understand a visual BOM and routing really well and understand like how to connect with all the EDI systems out there so you can get orders from Caterpillar automatically, or we connect with your suppliers to get lead times and prices automatically, things that you likely wouldn't be able to do on your own very easily. And you'll stitch it together like a custom suit, however you want to, or rearrange it like Legos as your business changes. And there's some other people who are like, to heck with it. I'm going to try to differentiate in other ways. I'm just going to buy some off-the-shelf software and just use it as best as I can. I think that the implementation of that software will be much faster than before. I think people's ability to stitch together these components is going to be much better than before. And I think that people's ability to create really rich custom software experiences will be much better than before too. It'll just be probably some mix of each three. You might want to custom engineer your like engineering timesheets, for example, because no system has something exactly as you want.
Right.
But your scheduler is just going to work this way because that's exactly what you want, and you just need to stitch it together. That stitching it together used to take 5 engineers, 2 years to integrate everything, right?
Right.
Well, if a bunch of agents in Claude just know Fulcrum and know whatever other system that's out there, well, it'll stitch it together for you. And as each of these systems change, they restitch it together automatically. So it's just a much more, it's like another order of magnitude of dynamicism that's happening. And I think that's really exciting.
Yeah, especially when I don't know if you've Outerbox was here yesterday, and I saw that presentation, and then I thought about today's conversation, all the AI stuff, and all the software that's going on, and the in-house software that's being developed. I'm like, wow, wouldn't it be neat if we had IIoT platforms connected seamlessly to production scheduling, connected seamlessly to scheduling and order entry, all that kind of stuff, but then back further to sales and marketing to say, hey, this is where we should focus our sales efforts because this is where we make the most money.
That's right.
But there's always a balance. This is where we make the most money, but the sales and marketing guys are, yeah, but this is where the customers are.
Yep.
And so I mean, the world cannot shift to what you like.
Yeah.
It's still a business. You gotta find a niche where you can compete. So kind of talk about that as far as how that could pop, the potential there.
No, I think everything, we've created all these frameworks, and they're ones that I've learned, that you've learned, that we've heard presentations about job costing, about return on invested capital, about all these different metrics, right? All these different ways of looking at your acid test ratio of how much your inventory turns, blah, 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 blah. And a lot of this is because we all need some simple ways to look at our business and say, are we doing well or not, right?
Right.
But all of it is a proxy to what you just said. As a job shop, you have just 3 things that you're doing. You have capability. So do you know how to do it? And how well do you know how to do it? And to what tolerance and what size and what gauge and whatever. And what machines and whatever. Capacity, how much stuff is going on in the shop right now? Could you even handle more by what timeline, at what price, and et cetera, et cetera? And then reaction. If the market changes, you got to change your machines and your people and your processes quickly enough that you don't go out of business. Well, if the rate of change goes up, we need to automate, essentially, the ability for us to understand our capabilities and our capacity and to sell it. And if we stop having the ability to sell it in the marketplace because no one wants, this kind of shape cut out by a laser in this way at this speed, and they won't say that, they'll just say no to all of your quotes, right?
Right.
If you have to go through all these weird ratios and analysis on paper, that might have worked 2 years ago when things were going slower, but if things are going faster, you got to connect those things directly. You got to get
Right.
the person on the shop floor that knows what you can do and can't do, and the person that's selling to talk directly to each other in a way that they can both communicate in a way that there's no ego and, like, I'm doing my job great. Why can't you sell it kind of a vibe? You see that a lot on shops. No, no, no. The market is changing so fast. We're one team now.
Right.
The capacity and capability changes every quarter, not every 3 years or 4 years or 5 years. Not every single time Trump comes out with a new machine. It's every quarter the market might change a little bit in our local geography or within our customer supply chain, and maybe we'll lose some, but we got to go grab one faster. That's what happens when the harmonic frequency increases so much. You just got to connect directly.
Yeah, and there's an issue going on right now. I chatted with a few shops today about what are they going to do with the long tail, because with data centers and the volume that people are seeing these days,
Oh yeah.
the long tail, it's hard to serve them all, and
Well,
and
it's,
and, and sometimes they call them,
no, for
and
sure.
and but I'm considering all this, so perhaps they don't need to in the future if it's a well integrated. Hey, this is how we can squeeze it in between.
That's our vision. Our vision is what we're seeing play out today. We see some of our customers lose data center component manufacturing. We know it. Like, you can see it from the drawing, right?
Hmm.
And then all of a sudden it appears in another customer's sales orders. Well, what happened is that Meta didn't want to deal with 500 different vendors. They just chose one. Well, that one vendor can't do it all. And they're just subcontracting it out to another one of our customers anyway. And they're just collecting a 20% margin, and our customers make less money.
Right.
And you see it, right? It's not as if somebody just has all of these machines, right? People are waiting for the exact same machines that somebody else is.
Right.
It's just that one company is making money coordinating, and that's really what we're doing. Well, for us, we have no remorse for those companies, really. If we can connect our customers to the end users directly, well, that coordination cost of managing all these vendors is all digitized and automated.
Right.
I actually think that if we're successful at really pushing this through, the vast majority of $5 to $100 million manufacturers will benefit a ton.
Right. Right.
And all the companies that are really just shuffling material around, they're probably going to go away pretty quickly.
And now you mentioned that, all right, they're going to grow in size, but not headcount.
Correct.
What enables that? Considering we're dealing with physical sheet metal here.
Speed.
Okay.
It's like table turns in a restaurant. You have the same restaurant, but if everybody eats in 15 minutes versus eating over 3 hours, you're just going to have way more people go through the shop.
Right. Right.
Same thing. If it takes you 5 hours to do a quote, 2 hours to annotate a drawing, 3 hours to call the customer, talk to the customer, whatever it may be, but now it's 15 minutes for each of them. Just think of the throughput. And no different than what happened with lasers, right? Or CNC machines. More automation just means more throughput, just means $1-2 million machine, right? But that's just ripping out material so fast, it's actually probably just laying there because you don't even know where to put it afterwards, right? Now, what if that production manager doesn't have to look at everything? There's a machine that just tells it, this goes here, this goes here. Well, just think of the brain automation that creates so much more throughput.
When I visit a shop, I tell you, I see, again, parts spend most of their time sitting between operations. And so if you can get rid of that, but also the office. I remember visiting it was when I was doing a quick response manufacturing case study where they had what they call Q-Rock, which is a quick response office cell. And it was literally a line of people who would send work orders through the process and to get it through. So it was kit-based production in the office, so to speak, right? Because everybody was together. We're not going to populate our inboxes. They realized it took us 4 weeks to process these orders. And now AI is able to automate a lot of that, especially when it comes to, I know some shops, in fact, on this podcast, they've told us, hey, we're not going to tackle some of this work because look at this contract, look at this NDA, look at all these things the audits I have to do. There's a cost to these audits. It takes me forever to deal with this, all the paperwork.
Yeah.
But now I've talked to them recently, like, now, wait a minute now. The AI can look at a contract. AI can look at this or that. And it's an interesting time. It's like, and that way they could accept a job from the huge company that they'd like, but they just don't have the processing bandwidth in the front office. Well, now they can, and and unlike larger companies, they've never had the processing bandwidth,
and they never will until now.
Exactly. So that's what makes it so exciting, and especially for such a now. Do you think is this going to be remain as fragmented as it always has been?
I hope so. In many ways, right? Like, one of the things that anchors us in our mission and our vision is if you look across nature, distributed systems are just more successful. They're more resilient against shock. They're more innovative. They are more mimetic. If you have like really high amounts of incest and any sort of like cultural heritage, you have a lot of genetic diseases. There's just a lot of issues with centralized systems. Like we really believe one of the big innovations of capitalism plus freedom in America is this distributed way of manufacturing. And if you look at other countries that have capitalism and freedom together, like Germany and Japan and other places, France, all these places around the world, what you see is distributed manufacturing, right? You have all these different smaller shops that are like you said, fragmented. The problem, I think, and again, not to be a fearmonger, you may have been able to have the luxury of waiting in the past to digitize your systems. You cannot feed analog data into AI nearly as well or at all as digitized information. Like
Right.
there are so many shops where the vast majority of their information isn't digital at all. It's in someone's brain. It's not even written on a piece of paper. It's not even written in handwriting, right? Even that we could probably do something with.
Right.
And that's a painful process. And these people are retiring and they're taking a lot of knowledge with them. I think there's an urgency fear and a capacity fear. Like all the software shops in all the world aren't going to be able to digest every shop. And so I think there's a lot of people that have an intuition that they can wait. I don't think they realize they can't wait because even if we have AI automating all the implementation of Fulcrum, let's say, the part we can't automate it is the part where you have to actually just tell something, this is what happened. Like, this is how you make this part.
Right.
This is what the bomb actually is. Can't just all be in your head. And after you do that, you got to change the process of how your shop works. That takes a long time. That is hard. You can assist a little bit with AI, but that's just cultural change. People have to get acclimated to something different. Some people might have to leave. You have to hire new people.
Right.
And then you can use this new technology. Like that's how far behind a lot of shops are.
Yeah. Well, that you got to crawl before you walk. But on the other side of that, I mean, I'm just uh, viewing my recent travels over the last decade. If I go to a shop in Japan or if I go to a shop in Europe, they've always been smaller quantity, smaller cereal. That's what they say, small cereal, small cereal. So small cereal runs 5, 10 pieces, and they not necessarily have been automated by software, but they have geography on their side. They drive it 5 miles down the road.
Yeah, exactly.
Or 10 miles or 50 miles, or 50 kilometers. And same in Japan. They are right next to, they have manufacturing clusters, and they're all there to support. It's distributed, but it's all kind of hinged on
Yeah.
large. And uh, but in the U.S., it's always the order sizes have always been larger because of distance. But I'm thinking, okay, yeah, well, but if we can really dial it in, does it need to be? Because how much excess inventory is there really in the system?
A ton, a huge amount. We see it. We see it in our data. And imagine this. Imagine that you are a machine tool manufacturer. You're probably really frustrated that you keep making your machines better and the shops that you sell to can't absorb that improvement. They're like, we don't need this to be faster. We don't need like a 400 kilowatt laser. Like it doesn't matter if you
a kilowatt. All right.
it doesn't matter if you just blitz all these materials and we don't even know what to do with it. We got to go coordinate a little bit better. Imagine that you're like FedEx or another logistics company and you've figured out how to take 15 parts and transport it across the world in 2 days. And you're like, no, we're doing larger things. We're going to do whatever. The rest of the world is here. You know what I mean? Is at some level. It really is bottlenecked on digitizing this manufacturing component. And once you do, though, every shop that digitizes, the tide is just going to float you. Like you won't believe if you're in the first half of this wave, just about how much extra benefit you're going to get by responding to customers faster, having like shorter lead times for the exact same volume of work that's going through your shop. You're just going to win work at higher margins, and you're just going to make a lot of money.
Yeah.
And it's happening today.
Just more of a nuts and bolts question, but I remember years ago visiting a fabricator in Georgia, and I visited on a very bad day because they were implementing. I'll leave the software package unnamed, but they had reams of paper everywhere.
Oh yeah.
And they had they were reviewing bombs and reviewing numbers and reviewing how they labeled stainless steel 304. Sometimes it was SS304, and sometimes it was stainless 304 in the data. And so they had to parse through and manually correct all these things.
I remember those days.
I assume that's changed now.
It is.
So explain.
So these systems are tokenized, as in it doesn't actually understand a full word. It understands components, bits of words. And so if you make a typo and it breaks the word up into 3 pieces or 2 pieces, it semantically in a knowledge graph actually kind of knows what you mean either way. And so these are not deterministic computers. When you put the same input into Claude, the output is different every single time, which drives people nuts, especially manufacturing. But the benefit of it is that you forget how much of your inputs are all over the place. Like you said, SS304 or stainless steel 304 or stainless S304 or whatever it may be. What you get from a probabilistic computer is the ability to handle probabilistic inputs. And I think as humans, we forgot how much torture and bullying and just absolute corporal punishment we pushed on our teams to get people to input the right job number into the right field exactly right over the last 30 years, because that's what that generation of computers needed. I'm not encouraging people to get sloppy, but one of the biggest benefits of this probabilistic computer renaissance is that we can now digest probabilistic inputs.
Right.
And so what people will start to realize is that all the stuff you struggle to get into your data systems 30 years ago or 20 years ago or 10 years ago, even 5 years ago, that actually becomes a very small piece of all the data that's actually out there. You actually just could only handle inputting all that information. Think about all the stuff that you just write on a piece of paper or put in a spreadsheet or do it in a separate tool or get an instance of Trello or something like that, just because there's no place for it. You got to create a custom field, do this, blah, blah, blah. Well, just imagine if it's just a pile of data and this probabilistic engine can just chew through it and pop it into mostly, almost all correct places, but just imagine how you can just pile more stuff into it. It's no different than automating any process,
Right.
like an automated deburring machine or anything, right? Or a time saver. Like almost everybody has a time saver if they're a sheet metal fabricator, right? These types of things actually just increase the volume of activity.
Right.
You're just going to have way more stuff. And then the AI is going to analyze even more stuff, and the answers are going to get even more better, and it's going to understand your shop even better and make this probabilistic ingestion even better, and you're going to pile even more stuff into it. And at some point in time, you're going to have all the information in there that you just wrote off. You're like, ugh, that's a piece of handwriting, or it's like, Tim's sheet is different than my sheet. Just put both sheets in there.
Yeah.
And now all of a sudden, all these streams flow in, and they're not perfectly deterministic on the way out, but it's way better because it's 1,000 times more information, categorized, analyzed, 99% accurate.
Right.
I think people just don't understand how little information is actually being processed by humans and machines in your shop, and what a revolutionary change is going to be when all the data is analyzed automatically.
And it opens the door for some technology that I've seen for years where, again, there's all these puzzle pieces that are out there. They're like, wow, wouldn't it be great? Because like years ago, I went to, I think it was Modex, and saw Intel had a booth there, and they had their vision systems they use it for various industries. But I said, hey, do you have a sheet metal application for this where it actually analyzes the edge quality of certain parts? So, oh yeah, we digital map, and I'll show you. And he brought me through a sheet metal, and I'm like, oh my gosh, this is amazing. And of course, it's not implemented anywhere because, all right, where do you connect that?
That's exactly right.
And now I see, well, now I know maybe, now that you stitch together these business systems, I'll call it, job shop business system, basically.
Yeah.
And say, hey, connect that to, then you've got an eye right before your flat part deburring machine. It says, all right, these are the parts that have dross, and they inspect it and inspect it through the process. You have 100%, it's 100% inspection throughout, and goodbye rework. Well, of course it's not going to happen.
Yeah,
but you at least get closer to that, and implementing such a thing isn't so pie in the sky anymore.
And if something happens, you can point to it, take a picture of it, and from the grain pattern to the fraying on the edges to other data that we have in Fulcrum, let's say, it'll tell you, oh, this was this part from this run, and here's what probably happened, and here's how you fix it next time. I'm going to go update the work instructions, add another pre-process, and probably not use the same outside vendor. Done. In plain English.
Utterly change root cause analysis.
Right. Instant.
just instant root cause analysis. Bam.
Longitudinally across every stack of data in your whole company.
Wow. And it could even do multi-cause analysis because there's always multiple causes, but
Correct.
you could just always, hey, this contributed to that.
And these root cause analyses right now that feel very almost like a death sentence or like a crime report or whatever it may be, will just sound more reasonable.
Right.
It'll be interrogatable by English. You'll be able to say, well, what are some other reasons this could have happened? Well, you could say that it was this employee plus this vendor, or you could say that we should add another process for receiving, or you could say, actually, we should probably just re-engineer the way that we're doing this part and not use this machine. All three of these things could be one of the ways that we fix this problem. Versus right now, every single quality root cause analysis is like, Sonny's an idiot. He should not be out there. Look at all these NCRs against him, blah, 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 blah. There's a pattern here and it's all his fault, right? And it might be, it probably always is my fault. But I think the thing that people will really enjoy when data becomes much more addressable is just how reasonable answers become. And you're just going to make more incremental changes to your shop because all of them just seem more reasonable. Because once you absorb more complexity as a human, like a child that doesn't understand complexity, there's very unreasonable. Do you know what I mean? I just need my pink pajamas. But if you can understand that there's laundry and there's like a budget and like there's supply chain issues and all these other things, well, you just get more reasonable as complexity gets absorbed. These data systems are going to be more reasonable to you as well.
Right, right. Now, just to wrap things up, because we've been chatting a long time here, we've been really geeking out, and this is great, and it's great to just have this, vision that it sounds like a panacea. I'm sure it won't be. It never is.
Never is.
But there is great potential. But I've been covering metal fab since 1998, and it's a family business, even if it's not a family. Even at some of the larger companies I visited, it's not a family owned. It's a familial business. They're very the relationship between folks is what drives things,
Absolutely.
positive or negative. So in the future, how will software affect that job shop culture in this distributed manufacturing environment where still, yeah, you said we'll grow to about 30, 50 million, but we're not going to have big corporate behemoths probably. So yeah, what's the future metal fabrication family look like?
I think that it does whatever technology has always done, which is it raises the floor and maybe drops the ceiling a little bit. Um, as you looked at companies that were in the early 1900s, mid 1900s, before automation really happened, failure rates were a lot higher. You just had a lower floor. You could just lose a lot more money really quickly. Now, yeah, you could go buy a bunch of machines that you don't need, et cetera, make some bad decisions. But we see that the generational success rate go up with more technology. We actually see more continuity with more technology. The floor goes up. Like you'll just lose less because you'll see most of the things that could kill you.
Yeah.
You might not have as much opportunity to have one killer year, but if you look at the history of investing, of business, if you could just guarantee that every year you don't lose money in the market, even if you made less money every single year, you're going to compound the heck out of that thing, right? You're going to be way richer. And I think that's what's happening in business already, is that we're seeing the people that actually have the real capability, real capacity, that really figure it out, that have the grit and the gumption, they're going to be rewarded with a much higher floor, with the tax of just a small lower ceiling, which actually I think preserves familial links, increases the probability that somebody that goes and studies law and wants to come back in the family business can learn things. All the data is available. They can talk to an AI that teaches them everything. They can absorb this information and refunnel it. I actually think continuity will go up dramatically.
Right, right. And of course, there's all this chatter in the investment community and the worry that, okay, AI is going to take over every job. But what I see, just at least from my perspective, is like I see a lot of BS jobs going away, where you had these people there just because you had to have a lawyer look at it, or you had to have accountants there because the accounting system was this complicated. You needed something, and they're not necessarily BS. I don't mean to say, I don't mean to tell, I don't want to get sued or anything. But anyway, but it just seems now it's like, all right, this focuses on quote unquote real production,
Yeah,
real value.
I'll pull out some of the words and I'll say, yeah, I think there's BS work that we do as a civilization, but I think the word to hone in on is focus. I think every job is going to intensify. In software development, you had to wait for your code to compile. So you'd go play some games or whatever it may be. Or if you remember back in the day before CAD, you actually had to draw stuff. So like how much of your day was just spent drawing the thing that you'd already imagined. Well, now that we have CAD, we're still drawing, but it's much faster. And so we're just designing more. I think there's a lot of jobs where you're going to have the same number of people, but the intensity of that job is going to go up. And if you hated your core job and you just loved all the procrastination that came with it, all the BS, all the fluff, that fluff's going away, and you probably want to change jobs because the thing that you hated that you just got to procrastinate 90% of the day away, that's going to be your whole day. Now, if you're somebody who just loves that part of the job and was always frustrated by the fluff, you know exactly the type of person, right? They just love doing that job. You're going to have a great time and you're going to be much more valuable. You're going to make more money. And so I think we're going to reward the right people. The people that love their job and are industrious are just going to be so much more successful. And isn't that a good thing, you know?
Oh yeah, great. And as a software company, you can, do a podcast and write software at the
All
same
at the same
time.
time. That's right. My job is intense too. I'm flying to New York tonight.
So three with 3 laptops on the podcast table here. Well, again, Sonny, thank you so much for your time. It's been a lot of fun. Again, to you all, thanks so much for tuning in for this episode of Next-Gen Metal Fab Podcast, and we'll catch you next time.
The Next-Gen Metal Fab Podcast is a production of Fabricators and Manufacturers Association and part of the FMA Podcast Network. The show is hosted by Tim Heston and Caleb Chamberlain. The podcast is produced and edited by Garrett Slager and Dana Weicker. Additional production support by Dan Davis, Andy Flando, Mike Owens, Billy Culpa, Elizabeth Gavin, and me, Sarah Spring. Thank you for listening.